Welcome to Finance with Fairbanks, where real-world finance comes to life. Hello, my name is Dr. Fairbanks, and in this episode, we're going to work through some basic time value of money calculations. To get started, you'll want to download this slide deck and get your financial calculator ready. There are going to be 21 total time value of money questions that we will work in this video. To get started, you'll see this question says, today you deposit $5,000 into a bank account that pays 4% simple interest. How much will you earn over the next 5 years? To answer this question, we need our simple interest formula. And recall, this formula does not require compounding periods per year. It doesn't matter if it's daily compounding, monthly compounding, whatever. We'll just assume yearly compounding because that's what this equation does. We simply take the years times the rate times the original deposit or present value. We can see that we have 5 years times 4% times $5,000. In this particular example, the interest is not allowed to accrue upon itself, so there is no interest earned on the interest. We'll use our calculator here, and we will take 5 times 0.04 times the original $5,000. And you can see that in total, this particular account would earn $1,000 in total simple interest. That is the answer to question 1. All right, question number 2. Gwendolyn deposited $20,000 into her savings account. The account pays 0.75% compounded annually. This is 0.75% in decimal form. That's 0.075. Calculate the interest on the interest earned on the account over the next 10 years. To do this, we need a set of formulas. The first formula that we need is total interest. We know that total interest is equal to the future value of that account minus the original present value. Next, we'll calculate the simple interest that was earned on the account using the same formula that we used in the prior example. Lastly, to find the answer to this question, the interest earned on the interest, we will take the total interest minus the simple interest. That should be reflective of the total interest earned on interest. So this is a 2-step problem, and the first step that we want to do is we need to solve for the future value. To do this, I will use my time value of money parameters and write them down in the order that they match on the calculator. The number of periods is going to be 10 years. Remember, everything that we do in these basic problems will assume annual compounding, so the number of periods is going to be years. The interest rate is going to be 0.75. Recall that when we entered our interest rate, our rate of return, our discount rate, whatever the percentage rate is, into our IY part of our calculator for that parameter, we always put it in percentage terms without converting it to decimals. So that is 0.75% in the calculator. And then we'll put in the present value. Our cash flows have to have a story because we're depositing this money into an account. It'll be a negative $20,000. There are no periodic payments. No additional cash is being added to this account over the next 10 years. And we're trying to find what is the future value of this account 10 years from today. What we're going to do is use our financial calculator. Step 1 in all time value of money problems is always clear your time value of money buttons. So hit the second button, hit FV. That will clear all 5 of the parameters and erase all the information stored in that part of the calculator. We'll hit 10 and N, 0.75 and IY. We'll hit 20,000 and the plus minus sign to convert it to a negative for PV. We'll hit 0 for payment, and then CPT FV, essentially compute the future value for this account. We can see that that's $21,551.65. That's step 1. Step 2 now is to calculate the simple interest that was earned on this account. Well, I guess we can go ahead and calculate the total interest now. The total interest earned on the account is the future value that we just calculated minus the original account balance. And if you're wondering why the interest earned on this account was so small, it's because it was only paying 75 basis points or 0.75% each year over the course of 10 years. Next, just like we did in question number 1, we need to find the total simple interest by taking the years times the percent times the original deposit. We can use our financial calculator to do this. We'll take 10 times 0.0075 times the 20,000. You can see that that is $1,500 in simple interest. Last but not least, to solve this question, we need to determine the interest earned on the interest by taking the total interest and subtracting off the simple interest. Oops. This account earned $51.65 in interest on interest for this particular account. All right, question number 3. Kingston invested $7,000 into an account 8 years ago with a bank that pays him 5% simple interest. So the first part of this question is identical to question number 1. Cashton also invested $7,000 into an account that pays 5%. However, it is compounded annually. How much more interest did Cashton earn versus Kingston? Using the same methodology from question number 1, we will solve for the simple interest that Kingston earns using our equation, years times rate times the original present value. From this, we can see that Kingston put in $7,000 for 8 years at 5%. That is the simple interest formula. 8 times 0.05, $2,800 in simple interest. And now for Cashton, it's a little bit more complicated because we actually have to find the future value to solve this problem, even though it doesn't say specifically find the future value. We'll go ahead and set up the parameters as they match in the financial calculator. Number of periods here, 8 years at 5%. Remember, we plugged that in as the value of 5. Present value, cash flows have to have a story, so negative 7,000. No payments being made, and we're trying to find the future value of this account. Using my buttons here, remember step 1, always clear your time value of money. 8 for N, 5 for IY, 7,000 negative for my present value, 0 for my payment, compute future value. You can see that that's $10,342.18. The total interest that Cashton earned on his account was significantly higher. We take that future value and we subtract off the original amount, and we can see that he earned $3,342.18. But the question asks, how much more interest did Cashton earn versus Kingston? So we're comparing the $2,800 to the $3,342.18, and that difference, hopefully this is not surprising to you, is the interest on interest that accrued in Cashton's account because it was compounding on an annual basis. And we can see that that's $542.18. That's how much more Cashton earned versus Kingston because his account compounded annually, whereas Kingston's account only had simple interest. All right, question number 4. Fair & Co. invested $250,000 at 6% compounded annually for 2 years. Calculate the future value of the account. Now, recall the 3 steps that I taught you in the chapter, and that was, number 1, read the question, figure out what it's asking, which bucket does it fall into. This is obviously a basic future value calculation. We're trying to find the future value of this account 2 years from now. They are going to invest $2,500 at time 0, that's today, and we're going to shift this cash flow 2 years into the future. Not really necessary to draw the timeline here because there's only one cash flow and we're just trying to figure out the value of that account exactly 2 periods from now. And then step 3, you just write your time value money parameters as they match in your calculator. You'll see me do this step over and over again in today's video. Our N is 2, our IY is 6, our present value is a negative $250,000, no payments, and we're trying to find the future value of the account. Again, clear your time value of money, 2 and hit N, 6 and hit IY, $250,000 plus minus on the PV, 0 on the payment, compute future value. It appears that the future value of this account is $280,900. Okay, that is it for question number 4. Question number 5. You have $25,500 to invest for the next 30 years. The account promises to pay 7% per year for the next 10 years and 9.5% per year for the last 20 years. What is the future value of this account? The question is asking for FV30, but this is a multi-step problem. First, let's draw the timeline. Obviously, I'm not going to draw 30 ticks on the timeline, but what we'll do is this. So for the first 10 years, you can see that the account is going to pay 7%, and for the last 20 years, the account is going to pay 9.5%. In order for us to solve this problem, the first thing that we need to do is we need to take this time 0 cash flow and we need to find the future value of it at the end of year 10 using a 7% discount rate. Once we have FV10, we can then send this cash flow forward to time 30 to find the answer to this particular question. What we're going to do is we're going to set up our time value money parameters. We're going to solve for that future value exactly 10 periods from now at a 7% compounded rate. Again, we don't put the percentage here in the calculator, we just put the value of 7. Our present value is going to be a negative $25,500. Payment is 0, and we're trying to find this future value. All right, using our calculator, 10 for N, 7 for IY, 25,500 negative. Our cash flows have to have a story. Let's make that PV. 0 on our payment. Go ahead and compute FV. It appears that the future value of this number is $50,162.36. Now, an alternative way to view this problem is once we've calculated FV10, this becomes our new time 0, and we're only sending it an additional 20 years, again at that 9.5%. What I mean by that is when we set up our next group of time value of money parameters, what is going to be the FV, or excuse me, the PV here? The PV is that FV10 that we just calculated. So that goes directly into my present value here. I will change the sign to be a negative because our cash flows have to have a story. That will result in us having a positive value for the future value. We're going to send in an additional 20 years at a much higher interest rate, 9.5%. Again, no additional cash flows being added to this account. We're trying to find the future value. All right, 20N, 9.5 on IY, $50,162.35 plus or minus. That becomes my PV, 0 on the payments. Compute the future value. We can see that the future value of this account, as well as the answer to this question, is $308,077.75. So it's a two-step problem. The first step is shift that initial cash flow to the end of year 10, then shift that cash flow to the end of year 30, which is an additional 20 years on that problem. Question number 6. Colette invested $6,000 into an account 10 years ago, then added $2,000 to the account 5 years ago. The account pays 7% compounded annually for the first 5 years and 4% compounded annually for the last 5 years. This is a historical perspective, which is kind of strange. So we have -10, -5, and 0. The alternative perspective from my view is we can treat this as 0, this is 5 years, and this is 10, right? There's 10 ticks total on the timeline. She put $6,000 into the account 10 years ago, and during that period of time, it compounded at 7%. Then at 5 years ago, she put in an additional $2,000, okay, and that grew or compounded at 4% for the last 5 years. A little bit tricky here, but what we're going to do is we're going to send this $6,000 and we're going to send it to basically time 5. We're going to shift this cash flow 5 years into the future, compounded at this 7%. Once we get there, we're going to add in this additional contribution, deposit, whatever we want to call it, to that number, whatever that number happens to be. And then we're going to shift that entire cash flow to today times 0 and solve the problem. So step 1, again, write my time value money parameters down. I'm finding future value in this problem. So N is 5 because I'm shifting this cash flow at 7%, negative $6,000, no periodic payments, and I'm trying to find the future value of this account. We'll go 5 for N, 7 for IY, 6,000 for present value, 0 for the payment, compute future value, $8,415.31. Now what we're going to do is we're going to write our parameters one more time. We'll put in a 0 payment. We know that. We know that the N is another 5 years. However, it's a much lower rate of 4%. For the PV, again, we're going to put a minus sign, but I'm going to take the $8,415.31 and I'm going to add that new contribution deposit of $2,000 to it, put a minus sign in front of that, and then solve for the future value of the account. As you can see in my calculator here, we already have that $8,415.31. So I'm going to add 2,000 to it. Hit equals. That's $10,415.31. Change the sign on it by hitting the plus minus button. plug that into my present value. Because I didn't clear my time value of money parameters, I'm going to re-enter all of these as they appear on the screen. So 5 for N, 4 for IY, 0 for the payment, and compute future value. That is the answer to this particular question, $12,671.82. So it took us several steps to get to this answer, but not too terrible. Okay, question number 7. Josh purchased $10,000 worth of NVIDIA stock 12 years ago. The stock appreciated 11% per year on average. Calculate the value of the stock today. Again, this is looking historically in the past at an investment 12 years ago. Hypothetically put in $10,000. We want to shift it forward 12 periods, and we want to know the value of the account today. That requires calculating the future value on this balance. So N is 12, IY is 11, PV is negative 10. Again, my cash flows have to have a story. It's a deposit, it's an outflow for me to hopefully have a positive inflow at some future date, 12 years from now. No other payments are being made. And find the future value. I will go ahead and clear my time value of money parameters now and enter them as they appear on the screen. 12 for N, 11 for IY, 10,000 for PV, 0 for the payment, compute future value. So the future value of this stock, if it averaged at approximately 11% per year, compounded annually, we would have $34,984.51. Question number 8. Lisa invested $50,000 at 7% compounded annually for 6 years. How much would she have earned if she had invested into an account that paid 8% compounded annually? What we're going to do is we're going to set up our time value money parameters, but we're going to do it twice, and I'm going to show you a calculator trick here. Our N is going to be the same in both scenarios, 6 years. One is going to earn 7%, the other is going to earn 8%, a 1% difference in those two. We are assuming $50,000 is deposited into both accounts. No additional payments is being made. Both accounts compound annually. We want to know the future value of each account, and then ultimately we want to know what is the difference. How much more would she earn if she got an extra 1% per year for 6 years? 6 for N, 7 for IY, 50,000 for my present value, 0 for my payments, compute future value. The future value of the account, if she were to invest at 7% for 6 years compounded annually, would be $75,036.52. Now, a really nice trick in our calculator, let's not clear it this time, is the only parameter that is changed is the interest rate. So the number of periods remains the same, the original deposit remains the same, and again, both accounts are not having any additional contributions or deposits. I'm going to hit 8 and change my IY. That's all I'm going to do. So I've only changed that one input parameter, and I hit compute FV. You can see now that the future value of this account, if it were to earn 8%, is $79,343.72. If we take the difference of those two numbers, we see that it is approximately $4,307.20 more. So that 1% over a 6-year period resulted in an extra $4,307 in extra interest. Question 9. Josh's coin collection contains 15 1949 silver dollars. His grandparents purchased the coins at face value when they were new. How much is collection worth now in 2024, assuming the coins appreciated at an annual rate of 5%? I write down my time value money parameters. This one is a little less straightforward. That's because I have 15 silver dollars. They were purchased at face value. That just means that the present value was exactly $15, $1 per coin. There are no additional coins purchased in this example. The annual rate of return is 5%. The number of periods will take the difference between 2024 and 1949, and we will compute the future value. 2024 minus 1949 is 75 years. We'll go ahead and plug that in for N. 5 is my IY. Negative $15 is my present value. 0 is my payment. Compute future value. The coin collection today would be worth approximately $582.49. Not too bad. Question 10. Tom made his first contribution of $10,000 into a retirement account. I would assume today. Assuming he earns 8% compounded annually, how much will he have when he retires in 40 years? What if he waits 10 years to make this contribution? Very similar to the problem where we were comparing the impact of a change in the rate of return on our future value. We are now looking at the change in the number of periods on our future value. In this example, there is fewer periods if we wait to make this contribution for retirement. My N will start with 40 at 8% for a negative $10,000. No payments being made. We want to find the future value. The only difference on this second setup is that the number of periods changes to 30 instead of 40, and we want to see what sort of impact this has. We know by looking at the time value of money formula, or the future value formula specifically, that the number of periods has a direct relation to the future value. So if you decrease N, or the number of periods, you will decrease the future value. But the question is, by how much? How much will they differ if you wait 10 years to make this contribution? Input the first set of parameters. 40 is my N, 8 is my IY, 10,000 is my PV, 0 is my payment. I'm computing the future value. It's $217,242.22. We'll use that same trick because only one of the input parameters changes in this example, and the parameter that changes is the number of periods. And so you might think, oh, well, 30 doesn't seem that much different from 40. Shouldn't impact the future value that much. Let's go ahead and see. Let's see what that does to my future value. The future value now falls to $100,626.57. So by waiting an additional 10 years to make this retirement contribution, you end up with less than half of what you would have otherwise. That brings our total difference in this example to $116,615.65. A huge difference those extra 10 years make, especially with an 8% per year compounded interest rate. We're about halfway through. We're on question number 11 now. Josh needs $50,000 for a down payment on a house 5 years from now. If he can earn 5.5% compounded annually, how much does he need to deposit today? This is our first problem where we're not dealing with future value because we're given the future value. We need $50,000, or Josh needs $50,000 for his down payment on the house. And the question is, what would he need to deposit today? That means it's a present value question, and we need to discount this $50,000 back to the present. We'll go ahead and leave the future value positive. That just means that the value that we get for the present value is going to be negative because that would be a deposit today, an outflow, keeping our cash flow story consistent. Our interest rate is 5.5% and the number of periods is 5 years. 5 for N, 5.5 for IY, 0 for my payment, 50,000 for my future value. This time I'm computing the present value. He would need to deposit $38,256.72 today in order to meet his goal. Question number 12. Fair & Co. needs $2.5 million 5 years from now to replace its truck fleet. If the firm can invest the required funds in an account that pays 3.75% compounded annually, calculate the amount the company needs to deposit today to fully fund the truck fleet today. Very similar to the prior problem, we know that they need $2.5 million exactly 5 years from today. Apparently they have the cash on hand to go ahead and put this money away. We're trying to find, well, how much money would they need to put away today in order to meet this future truck fleet replacement obligation. N is 5. Our discount rate is 3.75%. We're trying to find the present value. They're not going to make any additional payments or contributions to this account. They need $2.5 million in the future. N is 5, 3.75 is my interest rate, 0 is my payment. I'm keeping the 2.5 as a positive number. And our present value, or the amount that they would need to deposit today, is $2,079,694.21. That is the answer to this particular problem. Question 13. Lisa is scheduled to receive a lump sum cash flow of $3,000 in 8 years. Assuming a discount rate of 6%, what is the value of the payment in 4 years? Now this one isn't trying to be tricky, but rather than finding the present value today, they want you to find the present value halfway on the timeline. We know that she's going to receive $3,000 exactly 8 years from today, but they want to know what is the value, not today of this payment, but at time 4. We need to discount this back exactly 4 periods to find the value at time 4. My N is 4, my IY is 6. I'm trying to find the present value. There are no additional payments being made, and the future value is $3,000. If the question were to ask us to find the value of this $3,000 today, obviously the N would be 8, not 4. But they're trying to be a little bit tricky and make us find the value of this cash flow halfway to the present, which is 4 years back. And you can see that the value of this cash flow is $2,376.28. Question number 14. Josh is scheduled to receive a lump sum payment of $5,000 in 3 years and an additional lump sum payment of $3,000 in 6 years. Assuming a discount rate of 4%, calculate the present value of these payments. For this one, I'm going to draw the timeline so I can visualize the cash flows. There are more than one cash flow. I think I have too many ticks on the timeline. That's okay. Yeah, we only need to go out to 6 years. So here's my timeline. He's going to receive $5,000 at time 3. He's going to receive $3,000 at time 6. There's a variety of different ways to tackle this problem. One would be to bring the $3,000 to time 3 and then add it to the $5,000 and then bring that entire cash flow back to 0. Because there are only 2 cash flows here that we have to worry about, what I would do is I would bring this cash flow back individually to time 0, and then I would bring this cash flow all the way back to time 0. Once you're at the same tick on the timeline, remember I said you should never sum cash flows along a timeline. We can't sum those. They occur at very different periods on the timeline. But once you get to the same point on the timeline, we can add those cash flows together. What I mean by that is once we find the present value of the $5,000 today and the present value of the $3,000 today, we can take the sum of those 2 values. We'll just have 2 separate calculations. The first one is the $5,000. For 3 years, our discount rate for both sets of cash flows for the entire timeline is going to be 4%. We're trying to find this present value at time 0. The future value is that $5,000 that he will receive. Now let's set up the next one. We have N is 6, same discount rate, 4%. We're trying to find the value of the $3,000 today. I usually subscript these, times 0, and the $3,000 is what is expected to be received exactly 6 years from today. We'll use our calculator, clear our time value money inputs. 3 for N, 4 for IY, 0 for payment, 5,000 for the future value. Compute the present value. We can see that the present value of the $5,000 today is $4,444.98. I forgot to clear my time value money. Don't forget that. 6 for N, 4 for IY, 0 for payment, 3,000 for my future value. We're computing the present value. These are negatives because, again, our cash flows have to have a story, but the present value of the $3,000 today is $2,370.94. The last step here, because we need to find the total value of all the cash flows combined, is we're just going to add those together. So the complete picture here requires just taking the sum of these 2 numbers. Let's go ahead and do that with the calculator here. I'm going to get rid of the negative sign and just add 4444.98. You can see that the answer is $6,815.92. All right, about 2/3 of the way now. We're on question number 15. Based on the rule of 72, approximately what percent must be earned to double your money in 9 years? Let's recall the rule of 72. It's a really off-the-cuff way to figure out how long it's going to take to double your money. We take 72 years and we divide it by the percent, and that tells us the number of years that we would need. Well, in this problem, it's a little bit different because we're going to rearrange the formula. If we rearrange the formula, we take 72 divided by years. That tells us the percent that we need to earn to double our money over this period of time. They have 9 years. We're going to take 72 divided by 9, which is exactly 8. So we need to earn 8% per year for 9 years to double our money. To find the exact rate, we're going to set up our time value of money parameters. We're going to see how close and how well this rule of 72 happens to work. Now you're thinking to yourself, how are you going to set this up, Fairbanks? Because we don't have cash flows, specific cash flows in this problem. Well, what I'm going to do is I'm going to say that my present value is 1 and my future value is 2. Again, this is why it's so critical that your cash flows have to have a story. I'll show you in just a second with the calculator. If I do not put this negative sign in front of the 1, because that's an outflow, future value is an inflow, you will not get an answer. You'll get an error message on your calculator. We're trying to solve for rate. This is the first time in all of these problems that we haven't solved for present value or future value. We're now trying to solve for the rate. We know that we want this to double in exactly 9 years. Let me show you the mistake. We'll clear our time value of money. We'll put N is 9. We'll put 1 for PV. Notice I didn't put a minus sign. I'm just doing this to show you what would happen. So I put 1, 0, 2 in those parameters. I'm going to compute IY. Oh, you can't compute IY because your cash flows don't have a story. Well, I'm going to change that to a -1 for my present value. Now my cash flows have a story. I'll compute the interest rate. You can see that that rule of 72 did a really good job. It's 8.006%. So a great approximation there. And it usually does a pretty good job between about 4 and 20% in its estimation. Question 16. You have $500 today and want to triple your money in 5 years. Calculate the rate of return you must earn to meet this goal. Again, we're only given the 500. Let's set up our time value of money parameters here. We're trying to solve for the rate that we need. Present value is going to be a -$500. No additional payments are being made. And our future value is $1,500. And N is 5 years. What rate of return do we need to earn to meet this goal? Okay, we'll clear our time value of money parameters. 5 for N, 500 negative for PV, 0 for payment, 1,500 for FV, compute IY. We would need to earn an average rate of return of about 24.57% each year for the next 5 years. We'll talk about how much risk that would take once we get to risk and return. It would take a lot of risk to try to achieve that large of a return every year for 5 years. All right. Lisa has been told that she needs $25,000 today for every $75,000 she wants to have when she retires in 30 years. Calculate the rate of return that was used in this statement. We're trying to solve for IY. We know she has 30 years to retirement. She's going to make a contribution of $25,000. No additional payments. She expects to have, if she makes this deposit today, $75,000. What would be her average rate of return over this period of time? Clearing time value of money out, 30 for my N, 25,000 negative for my PV. Again, cash flows have to have a story or the calculator won't work. 75,000 for my future value. And now I compute the annual interest rate that would be required. It comes in at 3.73%. Question 18. Assume the total cost of a college education is expected to be $250,000 for your child when she goes to college in 12 years. You presently have $75,000 to invest and do not plan to invest anything further. Calculate the rate of return you would need to earn on this investment so that you have enough to fund her college education. I'm not going to set up a timeline. There are two cash flows here. We are trying to solve for the rate that will satisfy our goal. No additional payments are being made. She needs $250,000 at some later date. We're going to deposit $75,000 today, and we only have 12 years to make this happen. I'm going to clear my time value of money. 12 for N, negative $75,000 for my PV, 0 for my payment, $250,000 for my future value. Compute IY. We need approximately 10.55% rate of return each year for the next 12 years in order for us to reach our goal. All right, 3 more questions. In this next problem, you can see it'll be our first attempt at calculating the number of periods. In this case, it's years because we're assuming annual compounding throughout all these problems that we're working here today. You just won $25,000 and deposited your winnings into an account that pays 5.5% compounded annually. How long will you have to wait until your winnings are worth $75,000? We're trying to solve for N. We have a rate of return of 5.5%. We're going to deposit our winnings, $25,000. We're not making any additional contributions, and we want to know how long it will take for that value to reach $75,000. Clearing my time value of money, 5.5 for my IY, negative $25,000 for my PV, 0 for my payment. Did I put 25? $75,000 for my FV. Well, no, real quick. Yeah, I didn't put 25. $25,000 negative for my PV. There we go. And 5.5 for my IY. Compute N. Looks like 20.52 years. 20.52 years. 2 more questions and we're done. When you were born, your parents opened an investment account in your name and deposited $2,500 into the account. The account has earned an average rate of return of 6%. Today, the account is worth $10,729.68. How old are you? So I'm writing my time value money parameters. We know that our rate of return is 6%. We know that they deposited $2,500 when we were born. That account is currently worth $10,729.68. Clearing my time value of money, 6 for IY, $2,500 for my PV, 0 for my payment, $10,729.68 for my FV. Compute number of periods. You are exactly 25 years old. All right, folks, this is our last question of the day. How long will it take to double your savings if you earn 5% compounded annually? Well, the first approach is I'm going to use the rule of 72 because it's a great off-the-cuff measure to get an approximation of how long it will take. If I take 72 divided by 5 with my calculator, you can see that that's about 14.4 years. But now let's look at the approximation, the exact, using our time value money parameters. N is what we're trying to solve for. IY is 5%. There's no cash flows here. We know we want to double our money. I'm going to put PV as $1, negative $1. Payment is 0, and FV is 2. Clear time value of money. 5 for IY. Negative 1 for PV. 0 for payment. 2 for FV. Compute N. The exact number of years is 14.21. That concludes this video. Remember to smash that like button and subscribe. Until next time, goodbye.